Hey everybody, welcome back. Here we go. We're going to work on some more of electricity, on current electricity today. I want to start off just by having a quick look at our calendar. If you look at the calendar, you'll see that I have basically populated it right through the end of the semester with all the notes, activities, everything that's going to happen, planning to finish up on the 24th. So by the end of that day, I hope to have your final marks done. All right, so I should be able to let you know either late on the 24th or else in the morning of the 25th what your final mark is for physics. As we move through the last bit here, notice that there are still a fair number of notes ahead of us. I really think it's important for us to spend some time getting you ready for topics in electricity and magnetism because they have such massive ramifications in so many different fields. And I think having a sense of how it works might actually turn some of you on to the idea of what some of the possibilities are. All right, so you'll see that tomorrow we've got the Ohm's Law lab, mini lab. It's just a short lab. You'll see that's what this video is for today, to talk you through the lab, walk you through the lab, which I'm going to collect on Thursday. So I've already created a Dropbox for it. I'm going to ask you between now and Thursday to do the lab and to submit it. You can easily do it today. It'd probably take 30 minutes to do the whole lab. And then I'm going to do a note on Thursday about Ohm's Law. And then our last lab, which is a series and parallel circuits lab, you'll be doing on Friday. You may already have done something similar to this in the past. These are not gizmos. They're actually called PHETs. And you'll see as you work through them, they're pretty forgiving. So let's, with that being said, let's just kind of jump into the lab itself. Now it's not going to let me do this, is it? Okay, in Notability, I have already uploaded my worksheet for the lab. This is the worksheet that you're going to download, and you're going to basically fill in the pieces here. So I've already done one. You're going to be looking at the relationship between voltage, current, and resistance in a circuit. So I've already done the first one for you here. You're going to be starting with 800 ohms of resistance. We're going to talk about resistance in a moment, and with 9 volts of potential or voltage. Okay, so let's just see. This is going to let me. So I did a Google search for PHET. Come on. I'm not sure if it's thinking about it or what it's doing. It should bring up the lab, the PHET. For some reason, it doesn't look like it's doing anything. PHET simulations, PHET battery circuit, PHET DC lab. Okay, so there is one there, Circuit Construction Kit DC Virtual Lab PHET. I don't know if it's going to allow me to record this, so I'm going to cross my fingers and hope. There it is, going to. Okay, so this is the PHET here. Oh, that's the circuit lab. I want the Ohm's Law lab. Sorry, I want PHET. Ohm's Law. Ohm's Law PHET. Sorry about that. So here's the Ohm's Law PHET here that you're going to be doing. And again, it's very quick and easy. We're looking at the relationship between voltage, how much energy the electrons get per coulomb, how fast they move in the circuit, and how hard it is, the resistance that they're going to meet along the way. Now, we haven't talked about resistance yet. Resistance happens when electrons try to get through either a wire or an insulator or a load. Most loads, times when I think about a resistor, I'm thinking about a load like a light bulb or the charger for my iPhone. Right? Whatever that load is, for the electrons to get through it, they have to push their way through. And as they push their way through, they have to use energy to get through it. So if I give them energy from the battery here, they have to use their energy to get through the resistor here before they can get back to the battery. Okay, and that's kind of the goal here, is to look at the relationship. So if I change the voltage and or change the current, then I can actually change the voltage and the resistance. I can affect the current, how fast I can speed up or slow down the electron flow. Notice that it's here in milliamps, thousandths of an amp. So I'm going to, again, looking at the worksheet, I did one for you already that has 9 volts. So I'm going to push the voltage up to 9 volts and the resistance up to 800 ohms. And you can see that the current goes to 11.3 milliamps. If there is more resistance, if I push it up to 1,000 ohms, basically, it slows down to 9 milliamps. If I go down to 500 ohms, it goes up to 17 milliamps. So the more resistance there is, the slower the electrons are going to move. So resistance slows down the electron flow, and as the resistance slows it down, electrons will, as they move through the device, whatever it is, in this case it's just a straight resistor, and the resistor basically is just a piece of a material that's got stuff embedded within it that slows down the electron flow. So there's the resistor. In a circuit, we often use a symbol for a resistor as that squiggly line. Okay, so let's go back to 800 ohms here. Okay, and then if you don't get it right on, try and see if you can get it right on, right on 800. It can be a bit tricky to get it exactly at 800, but I think it's doable. And then change the voltage from 9 volts to 8 volts to 7 volts, all the way down to the lowest voltage, which is 0.1 volts, right? And then you just keep recording the current in the chart. Now, if I go back to my worksheet here, again, you can see that I've done the first one for you. Once you've got your currents done in milliamps, you're going to convert them to amps. Okay, so again, remember, amps are milliamps divided by 1,000. So my 11.3 milliamps is 0.0113 amps. So it should take you just a couple of minutes to do all of this. Then you're going to change your resistance to 405 ohms, or as close as you can get to that number. If you can't get it exact, that's okay. If you have to use a different number, maybe 395 or 410 or 400 or whatever, just record in the box here what resistance you ended up using. So if you ended up using 410 ohms, just record on your symbol on your table here 410 ohms. Our symbol for resistance is ohms. That's this funny looking symbol here. I'm named after George Ohm, a German physicist. So change it to 400, and again go from 0.1 up to 9 volts and record your currents, and then do the same thing. Drop the resistance all the way down to 40 ohms. 40 ohms of resistance, again, or as close as you can get, and then change the voltage to those 9 different voltages. Record your milliamps, divide by 1,000 to get amps. Okay, once you're done, you're going to fill in the chart over here, or the graph on this side. So you're going to have 3 graphs on here, right? One of them is going to be when you plot your points. So I just did 9 volts, and I had a current. So for my first one, at 800 ohms, I had 9 volts and 0.0113. So I'm going to look up here at 9 volts, and I'm going to go across to 0.01. This is 0.04, 0.03, 0.02, 0.01. So 0.011 will be just past that. So my first point, let's change the color here, say to red. I'm going to put my first point right there. I'm going to put my 8 volt point whatever it is, and I'll end up with a graph that ultimately, I don't know if I can draw a straight line on here. There's probably a way to get a straight line. Anyway, I'm going to need a straight line that's basically going to go along that way. Then I'm going to look at my 400 ohm graph data, and I should end up with a graph that's going to look something like that. And then when I look at my 40 ohm data, I should have something that's going to look more like that. And you could probably, now that I'm thinking about it, I wonder if I put my ruler right on my iPad here, if I could get a straight line. Look at that. So that might be the easiest way to get a straight line. If you're using your iPad, you could actually cancel. You could actually just draw your, once you've got your points on there, just draw a straight line for your line of best fit. Again, notice it should probably go through the origin, because when there's no voltage, there'll be no current. Right, so that will get you through the worksheet, and then if you look at the rest, there's a few questions that you have to answer. Right, so it's very quick and easy. It shouldn't take long to do, and then just drop it into the Dropbox. Right, so I will leave you with that for today. Tomorrow I'll come back and I will put up the note for ohms